Hey, first of all, shout out to Jocelina for showing me this app. There's so many fun tools and toys, bro. I love this. My favorite one so far is the laser pen. Look at this. Looks like a laser shooting through the problem. Look at that. That's beautiful. And then it goes away. Oh, love it. All right, back to math. Let's see. Given the equation g prime of x below, determine the intervals where the graph is concave up, concave down, and any points of inflection, show your analysis, blah, blah, blah. Okay, so what's the point? The point is when you see concave up, concave down, or points of inflection, which is just a change in concavity, we're dealing with the second derivative. Okay, so let's jump to the second derivative here. Now, there's going to be a couple parts where the factoring gets a little tricky. I'm not going to review that in this video, all right? If you're struggling with the factoring parts, then plan to stay after school on Wednesday, okay? Or come see me during a study hall or make an appointment with me if you're struggling with the factoring piece of this, all right? I'm not going over that. This is just a calculus video, okay? All right, so let's take the derivative. This is a rational function, so we should do the quotient rule. I think that makes the most sense. So the derivative of the top is negative 12 times the denominator, x to the fourth plus 6x squared plus 9, minus, I'm going to put this in a bracket just so I don't forget, the numerator times the derivative of the denominator. Okay, this should not be, actually I know that this isn't a big deal for you guys. You guys are perfect with this. And then x to the fourth plus 6x squared plus 9, quantity squared. Okay, so what's about to get tricky is I have to distribute, and then I'm going to have to factor the bottom, and that's where I'm going to need you to possibly come after school, depending on your experience. Okay, all right, so right now I'm just going to distribute some things, so I'll distribute like, oh, let me get my laser. Hey, look at this. We're going to distribute this, boom, boom, boom. Oh, I don't know how I feel about boom for the laser. I need like a, nope, how about... I'm thinking like zing, zip, zip, and then I'm gonna zap that, and I'm gonna watch out for these double negatives. All right, yeah, I'll work on the sound effects for tomorrow. Sorry about that. All right, anyway, moving on. Let's just distribute this crap and get it together. So we have negative 12x to the fourth minus 72x squared minus 108. And I'm going to watch these double negatives over here. This is going to be plus 48x to the fourth, and then it actually becomes plus again, because you're distributing a negative twice, 144x squared. All right, and then down at the bottom, this is actually factorable. So if you're going to review on your own instead of coming after school, look up factoring perfect square trinomials. Okay, perfect square trinomials. This one we can get away with using some kind of like fake methods. So I'm just going to put it in brackets, and it's already squared so I don't forget. But I'm going to be looking for two numbers that multiply to 9 and add up to 6, right? So that's going to be x squared. That's how we're going to end up getting the fourth power, and then plus 3. Okay, again, if that was tricky for you, and this is going to be quantity squared. If that's tricky, then look up perfect square trinomial factoring, or you can come see me, okay? But the bottom of this is going to end up being x squared plus 3 quantity to the fourth. All right, and then in the numerator, let's just combine up some like terms, and we'll factor the bottom. I'm just going to run right down to the final answer. Let me just get the final answer here. What's this going to be? The final answer should be 36 x plus 1 times x minus 1 all over x squared plus 3 to the third power. All right. Actually, now that I'm doing this like live or whatever, maybe I will do like a warm-up with some factoring stuff tomorrow. That might be a good idea, just so we have something to talk about, and then if you go back and redo this problem, it'll make a little more sense. So yeah, I think we'll do a quick warm-up. Just I'll write them up on the board, and then we'll try them and talk, and I'll actually maybe do this exact one. All right, cool. So there's your second derivative. All right, that of course is the first goal. And now we need to come up with the intervals where it's concave up and concave down. All right, so I'm just going to get rid of this because you guys should have this in your own notes now. Jocelyn and I still need a way for this app to be perfect. I love the laser, but this erasing method not working for me. It takes too long. I don't get the cute little animation like I do with the other one, so I'm gonna need you to work on that. Figure out how to do it or tweet the developers or something. I don't even know. Okay, let's come up with the interval.